So we're looking at right triangle trigonometry, and we're just going to do the basics for this unit. Not going to get too deep into it. As you go into your other classes, you'll do a whole lot more with trigonometry. It's based off of the setup is just the fact that we have similar triangles, and when you have similar triangles, they're the same shape and the same angles, but the sides are not necessarily going to be the same. So I have an example of some similar triangles here, and you can see which angles match up together. And even though the sides aren't the same, they are in proportion of each other. So AB to BC is the same proportion as DE to EF, and so forth. So you can solve it by doing just a cross multiplication as long as you have at least 3 of the pieces. The angles that we're going to be looking at for this unit, like I said, is right triangles. So these right triangles, as long as the angles are the same, we could set up the proportion and we can check these ratios. So for instance, if I wanted to say 12 to 9, it has to be the same proportion as 16 to 12. And we can show that that's true by just reducing it. 12 over 9 reduces to 4 over 3. And 16 over 12 also reduces to 4 over 3. And we can do it as long as the sides match up. Then we can figure out all those different proportions. For the right triangle, it's really important that we're able to say what the hypotenuse is and what the opposite. So right triangles, we have a right angle. Opposite that right angle is the hypotenuse. And then depending on the angle, one side will be adjacent and one side will be the opposite. So if we're picking this angle down here, the adjacent helps form the angle and the opposite is straight across from it. And that would change if I had the angle up here, right? This is still always going to be the hypotenuse, no matter what. But now this is the adjacent side because it's helping form that angle, and this is the opposite. So we're going to define our trig functions. We have sine, cosine, and tangent. So sine is always going to be defined as the opposite side of the angle divided by the hypotenuse. Cosine is always the adjacent side that helps form that angle divided by the hypotenuse. And tangent is the opposite side divided by the adjacent side. A common acronym is SOHCAHTOA. So that SOH means sine, opposite over hypotenuse. The CAH, cosine, adjacent over hypotenuse. And the TOA, tangent, opposite over adjacent. And so here we have the SOHCAHTOA and these written out. So again, it's important to know which angle we're talking about so we can figure out which is the opposite and what's the adjacent side. So I have my right triangle, and we want to have this angle down here. Alpha is how you would say it. So the sine is the opposite side, which is 8. And the hypotenuse, again, is always opposite the right angle. So the sine of that angle is 8 over 17. The cosine is the adjacent side over the hypotenuse. So that would be 15 over 17. And the tangent is opposite over adjacent. So that would be 8 over 15. We also have 3 more functions. They're the reciprocal of the ones that we have, sine, cosine, and tangent. So cosecant is how you say that. CSC is the shortcut that we write it as, and that's just 1 over sine. So instead of opposite over hypotenuse, it becomes hypotenuse over opposite. Secant, the reciprocal of cosine. So it becomes hypotenuse over adjacent, and cotangent is the reciprocal of tangent, adjacent over opposite. So I'm not going to do all of these out, but I'm going to do a few of them out for you. If we have 2 of the 3 sides of a right triangle, we can always find the third one, by the Pythagorean theorem. So a squared plus 12 squared is equal to 13 squared. Right? A squared plus B squared is equal to C squared. So, square that, the 12 and the 13, and then solve for A squared. So I'm going to subtract 144, and I get A squared is equal to 25. Take the square root of both sides, and we get A is equal to 5. So now that we have all that filled in, then we can go through and fill in the rest of our sines, cosines, tangents, and then the reciprocals. So starting with angle A, sine is opposite over hypotenuse, so that's going to be 5 over 13. Cosine of A is adjacent over hypotenuse, so that's going to be 12 over 13. And tangent of A is opposite over adjacent, so that's 5 over 12. Here, all I need to do is flip these over, because cosecant is a reciprocal of sine, so that's going to be 13 over 5, and then 13 over 12, and then 12 over 5. For B, we're looking at the same triangle, but now we're looking at B. So sine of B is opposite over hypotenuse, so that's going to be 12 over 13. Cosine of B adjacent over hypotenuse, and tangent is opposite over adjacent. And again, for the reciprocal functions, all we're doing is flipping them over. So you can try B. I'm going to scan this and put it into Blackboard, and you can check your answers off of that. So for this course, we're going to be looking at our angles in degrees, but it's important to know that there's another unit of measure, and it's called radians. And so I have this written out for you so you can look at the circle. We know if we go one complete rotation, that's 360 degrees. But if I'm in radians, it's 2 pi radians. So these are the conversions. The conversion fact is 180 degrees is pi radians. And the difference between degree and radian is radians are actually measuring the segments that's moving, versus degrees is just measuring this rotation, whereas radians is going to measure, really is talking about the arc length. So we have convert 300 degrees to radians. So 300 degrees, we have pi, radians is 180 degrees. And then when you reduce 300 over 180, that's where you get the 5 pi over 3. So here, the next one, we have 5 pi over 2 radians. So we're starting with radians, which means we have to put radians on the bottom. And 180 degrees. So you can see that the pi's cancel each other out. And then I have 5 times 180 on top and a 2 on the bottom. So that's going to give me 450 degrees. I also actually should show you how to reduce these in your calculator so you're not trying to do them by hand. For this first example, we had 300 over 180. So I can just hit 300, hit the fraction key, 180, and hit enter, and I get 1 2/3, but we don't want mixed numbers. We want just a fraction form. So I'm going to hit second function and the fraction key one more time, and there it goes, just as a fraction. Alright, and then this last one, 30 degrees, and we want to convert it to radians. So the degrees has to go in the bottom, so these units cancel. And then that simplifies to pi over 6.